Good evening, everyone. Good evening, our audience. Welcome to our Astronomical Society of Penang monthly APOD session. So this APOD refers to astronomy photo of the day. That means every day this APOD website will share the selected APOD, the selected astro photographs. Sorry. So a brief self-introduction before we start. I'm Lai, a committee member of Astronomical Society of Penang. And today with me in this APOD session, we have Mr. Chai Hong Zuan, which is also our committee member and also currently studying his postgraduate in Tokyo Institution of Technology in Tokyo. So we have a friend there in Japan. And also shortly, Dr. Chong will join us. Okay, Dr. Chong is a former professor in University of Science Malaysia, USM, teaching the course astronomy. And currently, after he retired, okay, he is our president of Astronomical Society of Penang. So before we go into the APOD for today, a brief introduction about this APOD is, if happen that you are interested in this APOD, you can have a look or go to the website, the APOD website. Just Google search for APOD, and then you can have a look on there. Every day there's a astrophotograph published every day. So before we start, just a reminder to every one of you who are watching our live session, if you have any comments or you have any suggestions, you can just type it in the comment section below and you will respond to your comment as soon as possible. So our APOD session is held every month and the last Saturday of every month to share our thoughts, to share our knowledge about this astronomy or some knowledge related to space. So without wasting time, let's proceed with the APOD today, which is 26th of December. And just additional information is our APOD session is conducted in such way that every month we will select and present selected APODs for this session. So we will not go through all the photos, but we'll select about 15 to 20 photos and present it every month. So I'll do a simple start, and then our main speaker today will be Hong Zuan and Dr. Chong. Dr. Chong is here. So hi, Dr. Chong.
Hi, okay. So we just finished our barbecue session just now. Sorry. Hong Zuan, how are you?
Hi, Doctor. How are you?
We miss you. Okay.
Okay. So I think we start with today's APOD, 26th of December 2020. Yeah, and just before we start, we'd like to wish everyone who are celebrating Christmas a Merry Christmas. Although it's one day later, but then I think the atmosphere is still there. So the first APOD is also slightly related to this Christmas, because since yesterday is a Christmas, so today the APOD have a theme of this fox fur, unicorn, and Christmas tree. So the first APOD today. So can you all see the photos? The APOD today.
Yeah, beautiful, very beautiful.
Yeah. So this is the APOD for today. This is actually a star cluster and nebula. So it's actually a 2-in-1. So this is actually from this constellation called Monoceros, the unicorn. So this Monoceros is a unicorn. We call it a winter constellation. That means it can be seen during the winter. And so let's see. This is the nebula. The whole nebula, we call it there's a cone nebula. Okay, over here you can see the cone nebula, and then we have the stars clusters. It forms like a Christmas tree, so they call it a Christmas tree nebula, a Christmas tree cluster, and a cone nebula over here, and the fox fur nebula at the end behind here. Okay, so this photo, all right, the whole nebula itself and the whole cluster itself of this Monoceros, the the Unicorn constellation, is actually about 2,700 light years. That means it's very big. But this photo itself is actually 80 light years. That means from the leftmost to the rightmost, the left edge to the right edge is actually just 80 light years, because we have limited angle of the telescope and the imaging device. So this one is 80 light years. 80 light years is actually very far. That means the light travels from this very left edge to reach the very right edge here. It needs 80 years. So this is the concept of 80 light years. So it's a very, very huge distance. Okay. So, and a bit information about the author of this photo is actually Miguel Cloro. Miguel Cloro is a Portuguese famous astrophotographer and astronomer, and he is under this association of TWAN. We call it the World at Night. So the World at Night is actually association or NGO that put in effort to show the photos of landscape, culture, including science and technologies, images at night. All right. So the main theme of this TWAN is nightlife lah. So it's actually an association that published those photos as a bridge of art, science, and culture. And for your information about this TWAN, actually many countries they have, including Thailand, Indonesia, they have submitted a lot of photos to this TWAN and selected and published. And unfortunately for us in Malaysia, we still don't have any publication in this TWAN. So if anyone interested can try and submit your photos to this the World at Night association and see whether you can get your images published. So this is about the about this APOD today, and a little bit more information is about this Christmas tree clusters and this cone nebula over here. Is actually discovered by the same person, okay, called William Herschel in 18th centuries. All right, so he first discovered this Christmas tree nebula. All right, in astronomy, you will require a little bit of this imagination to imagine. All right, the stars actually, because of this triangular shape, it looks like a Christmas tree. Right, this is the base. This is a wider base, and then over here there's the tip, so it looks like a Christmas tree. So they call it the Christmas tree clusters. And 2 years later, which is at the end of 1785, William Herschel, after that, he discovered this cone nebula over here. So these two, this whole two-in-one APOD, the nebula and the clusters are discovered by the same person. Alright, so this is about APOD today. Let's proceed to the next one, which is yesterday APOD. For yesterday APOD is yesterday is Christmas, and it's a photo of a constellation. I think this constellation can be easily recognized, which is the Orion Constellation. Orion Constellation, captured by this Adam Block. Okay, Adam Block is this American professional astronomer and astrophotographer. He have a lot of images on. He have a lot of astrophotographs. All right. He's currently working in this Department of Astronomy and Steward of Observatory in this University of Arizona. So this one is the photo he captured in Arizona. So this is the Orion. So Orion is also a winter constellation and a northern constellation. So this is the best period to observe this Orion. And I understand that a lot of our members are currently in Junket Observatory for our ASP, Astronomical Society of Penang members night. So I'm not sure how is the weather over there, but at my place currently it's raining quite heavily. So maybe shortly when the rain stops and the sky is clear, you all can have a look on this Orion. And Orion is easy. It's easy to spot because the most significant stars is the Orion belt, the 3 stars in a line. So this is the Orion belt. Right, this is the Orion belt. So this is the most significant icon of this Orion constellation. Here's the Orion belt. Here's the Orion sword. Okay, Orion the hunter, the sword, the shoulder, the bow. So this is Orion, and we know that Orion. I think we learned before in science in school that Orion can tell us this direction. So how Orion tells direction is this. Along this Orion belt, all right, along this Orion belt is telling us the direction. It's actually from this Orion belt. Excuse me, Dr. Chow. This Orion belt over here, right, is actually along from east to west, all right, east to west. So pointing from east to west, this is the Orion belt. And below the Orion belt, we have the Orion sword. The hunter sword is pointing south. Right? So next to the Orion belt, you see the Orion sword, and this Orion sword is towards south. So it's telling the direction of south. And also in this APOD over here, okay, we can spot a few bright stars. Like this Orion belt, we have this Orion shoulder, okay? And also over here, there's a very bright star. So this is the brightest stars of this Orion. Okay, the brightest stars for Orion is this, we call it Rigel. And this Rigel is about 770 light years away, right? It's quite far. And the second brightest one is the Orion shoulder, we call it the Betelgeuse. Okay. The actual distance of Betelgeuse, there are many uncertainties, and the estimated distance is about 720 light years. It's slightly nearer to Earth compared to Rigel. Then this is the brightest, and the brightest is Rigel. The second brightest is Betelgeuse. And also in this image, we can see the brightest stars in this constellation Taurus, the moon. Right, this is called Aldebaran, the brightest stars in Taurus. So that means Orion is here, Taurus, right? And due east, that means below here, due east of this Orion, we have along this belt we will have another brighter stars, okay, which is not in this image, most probably blocked by this tree over here. All right, over here along this the belt axis, all right, there you will see a brighter star. Along this belt axis of Orion. The brightest stars is also the brightest stars that can be observed from Earth, which is Sirius. So that means blocked by this tree, Sirius is somewhere over here. All right. So in starting from October, end of October to February, okay, this is the Orion season, which you look up into the sky, you can easily see Orion. So end of the year, December, during the winter season, we call it the Orion season. So it's a winter constellation. All right, so this is about this image of this Orion and constellation. So let's proceed to the next APOD, which is we will go to 21st of December. Now, 21st of December is a special day for astronomy because 21st of December is the winter solstice, and also 21st of December, there's this great conjunction of Saturn and Jupiter, and also the next day is the peak for Gemini meteor shower. So, is it 21st? Sorry, it's 22nd. 22nd is Ursit. Gemini is 1 week earlier. Sorry. So for this APOD today, it shows the position of sun during sunrise. Okay, during sunrise. Okay, so starting from December, the winter solstice. So a little bit information of this winter solstice is during the whole year, winter solstice is the day where we have the longest night and the shortest day. That means daytime is the shortest, but nighttime is slightly longer. In Malaysia, because we are near the equator, so we don't actually feel the difference so much. But I believe Hong Zuan in Japan, he will have this experience that they have, during winter solstice, they have very early sunset and quite late sunrise. And yes, I think...
But usually, what I feel is that, like in Japan, the sun will rise quite early, like six something, and around winter solstice, the sun sets, I think it's around 4:30 p.m., which is very early. Yeah.
Yes, it's quite early sunset during winter solstice, but this doesn't mean that the earliest sunset is during winter solstice. And also doesn't mean that the latest sunrise is during winter solstice, all right? Because during winter solstice, it just indicates that the daytime is the shortest. And after winter solstice, the daytime will getting longer and longer and longer until summer solstice, which is 21st or 22nd of June every year. So Hong Zuan is in Japan now, so maybe you can experience that. You will slowly realize that sunset will be getting later and later, and sunrise will getting earlier. After
I did notice that.
Yeah. Okay. So this APOD is captured in the capital of Jordan called Amman. All right. And this is slightly different. This is in Amman, and it shows the sunrise. All right. This APOD is about sunrise. So from this APOD, we actually can see every month the position of sunrise is slightly different. All right. It's not exact east and it's not exact west. That means the position of sunrise is different basically every day. All right. Only during March and during September, which is during the equinox, all right? Equinox. The sun rise in exact east. Okay. During this winter, that means from October, okay, after the September equinox, all right, after this September equinox, the sunrise will slowly shift. Okay, will slowly shift to south. Okay, slowly shift southwards. That means on December during the solstice over here, sunrise is actually on southwest. Right? It's not exactly southwest, but then the sunrise is slightly towards south, so it's around southwest. Okay, and will rise at southeast and it sets at southwest. All right, will rise in southeast and set at southwest. And after the June equinox, all right, after the March equinox, all right, during the March equinox, okay, after this September equinox, it will slowly move back to north, okay, move back towards north, and then reach exact east, and then slightly move towards north again. Okay, so April will be northeast, May even more north until June solstice exact northeast. All right, on northeast is summer solstice. The sunrise in northeast and set at northwest, and then after that slowly move back to the south again. So this picture or this image is actually captured at different time each month. All right, it's not on the same time. Okay, and according to the author Zaid, okay, he said that the camera is actually facing exact east. So we can see during this equinox on September and March, right, the sun is exactly at the center. Okay, and slowly the position shifted. Now, I'd also like to introduce another method of this imaging is called Analemma, which is every day the same time you capture the position of the sun. So Analemma is something like this, right? In the same position, same time every day you capture one image of the sun. So you will realize at the same time the position of the sun is different. So this one we call it Analemma. And this is a very simple project. If you have a telescope, you can you do not actually need a telescope, but you can actually, with this a camera, you fix the position, and every day at the same time you capture the image, and then you can get this image. And a lot of astrophotographers in Malaysia actually have successfully captured the Analemma. Okay, even secondary schools in Penang, I think Heng Yi School have also captured this Analemma before. Okay, so this is about some simple and fun project can be done. Astrophotography project can be done at home or amateur level. Okay, it does not require much equipment, a simple camera, a nice landscape, and you can have that. Of course, you need to process the image. And next, we will proceed to the next APOD, which is the 20th of, which is day before this, 20th of December. Now, we know that on 21st, we will have this great conjunction of Jupiter and Saturn. But before that, you can actually see Jupiter and Saturn getting closer and closer. Okay, so we call it the conjunction. And something I like about this image is the conjunction together with this, they call it a volcanic great conjunction. That means they have the conjunction together with the volcano eruption. So this photo is actually captured by Francisco Soper, a Spanish astrophotographer, which is, this volcano is they call it, in Spanish they call it Volcán de Huago, or the Huago volcano, which is erupting, currently still erupting, okay, in Spain. So this volcano is in Spain. And you can see the Jupiter is over here. Jupiter and Saturn is just right above the tree. So I think the whole world, only at this place you can have the volcano eruption and this great conjunction. And something about this conjunction is, I think when we have this Saturn-Jupiter conjunction fever, quite recent. I think even ASP, we also have this observation. We have this live observation in this Pusat Falak Sheikh Tahir, PFST. And also, we also do another observation in Balik Pulau. And this conjunction can be seen by naked eye. Of course, with naked eye, you can see a bright stars followed by it's a very bright, it looks like a star is actually a planet. The very bright stars in the sky, and very near to it, you have also a bright stars, but slightly dimmer and smaller in size. So this is the conjunction of Jupiter and Saturn. Okay, it's very near. And the closest is on 21st of December, and we have observation on that. Of course, in Malaysia, we could not have the volcano with this conjunction. We should be glad. We should consider lucky in the sense that we don't have a volcano in Malaysia, but also we will miss this opportunity to have such great images of this conjunction and volcano. But anyway, even though we can't have this volcano with this conjunction, actually we can have the other way, which is slightly one day earlier, APOD on the 19th December. Okay, we can have the moon with this conjunction of Jupiter and Saturn. So a little bit information of this conjunction is, for this conjunction of Jupiter and Saturn, is basically, it means that we will see, from Earth we see this Jupiter and Saturn were getting closer and closer. The apparent distance is the closest on 21st of December. That means they are getting closer and closer. But in fact, it doesn't mean that during this conjunction, Jupiter and Saturn have the closest distance. Right? It appears to be closest, but it doesn't mean that the actual distance is the closest. Okay? And because this conjunction happens just right after sunset. So we can observe after sunset. And on the 21st is actually 1 day before the first quarter moon. So you can see the moon with, you can see moonrise together with this, you can see the moon, not moonrise, you can see the moon together with the conjunction. So such images can be captured in Malaysia. Just the difference that you will not have, the landscape will be different. And of course, this photo, okay, this photo is captured not on the exact date of the conjunction. It's slightly, I think, 1 week. Yeah, it's on the 17th of December, which is about 1 week before this conjunction. So you can see Saturn and Jupiter is actually still far apart. Okay, the closest is on 21st, and actually both are very near. Okay, and there are many people, amateur photographers, professional photographers, have captured a lot of image of this conjunction. So this is about the conjunction. And if you are so unfortunate to miss this conjunction this year, the next conjunction of Jupiter and Saturn, you have to wait another 60 years, which is around March 2080. Then you will have the next conjunction of Jupiter and Mars, Jupiter and Saturn, to be observed from Earth. So this is about all from me about for the APOD of December. So I'll pass it to Hong Xuan to continue the session. So that's all from me. Thank you very much. And just a reminder, if you all have any comments or any questions, feel free to type it on the comment section below, and we will get back to you all as soon as possible. So that's all from me. Thank you very much. Hong Xuan?
Okay. Now let me try to share my screen.
Lai, can discuss barbecue food here. Enjoy here got barbecue food.
Okay. Can you see me? Okay. Can you see my screen?
Yeah.
Okay,
barbecue,
right.
Yes, good.
Since just now Lai was talking about the Great Conjunction, so maybe I can show one of the image which is also related to the Great Conjunction of Saturn and Jupiter. Maybe I will do a little bit add-ons. Like in these pictures, you can actually see clearly, like from the November the 1st until the end of December. So this is actually the kind of like a simulation of prediction. So actually, when just some additional information. So when the conjunction is the greatest, the distance between the Jupiter and the Saturn is actually 1/10 of a degree. So how close is 1/10 of a degree? So usually we will compare to the size of the moon. So the apparent diameter of the moon is around 1 degree. So usually for sky observer, usually we will extend our hands, and the 1 degree is around the width of our finger. So if you extend your arm, so 1 degree is around the width of your finger. So it's 1/10 of the length. So that is about the Great Conjunction. And then okay, so I'd like to share about this. Okay, the title of the pictures is called The Diamond in the Sky. So do you see a diamond? This is a big bright diamond over here. So why this is called a diamond is actually this effect of a solar eclipse is called the diamond ring effect. So this is actually either the beginning, like the starting of the total solar eclipse, or the when the either the beginning of the end of the total solar eclipse. So this is just a little part of the sun is exposed as the shadow of the moon, move past it. So since the intensity of the sun is too bright, so when you capture it with camera lens or telescope, which will appears like a very, very bright spot over here. But anyway, what you can see over here, the ring, okay, this is a diamond, this is a ring. So around the ring, you will see some white glow and some red glow. So what are these? So the white glows around the eclipse is actually the corona. So this is the corona of the sun, which during the normal day, we can't actually see it because the sun is too bright. So also, the small red glows around the disk is actually the prominence, which if you have observed using the hydrogen alpha telescope before, I hope and I think you would have noticed and observed this before. So this is happened only during the total solar eclipse. And yeah, the next interesting ones is actually two photos published during the 13th of December and 17th of December. So both of these images about Gemini's meteor shower. So let's talk about the background first. So this one, the background is, as you can see, is Singlong Observatory. So this is one of the observatory under the, I think it's the National Astronomical Observatory of the Chinese Academy of Science, which is located at the Hubei province. So this observatory houses, maybe I can share a little bit of the information. Okay, so this observatory, which is this one, actually holds quite impressive telescope, which is a segmental mirror telescope. In short, we call it LAMOST. So it's a spectroscopic telescope, and in China they call it Guo Shoujing telescope, which is named after the very famous Chinese astronomer, I think, during the 13th century, I think. So as you can compare, the size itself is actually quite impressive compared to the other major optical telescope around the world. And this one, the background is in Italy. So I'm not sure about this place, but it looks like it's a very impressive dark sky. So maybe I will talk about, I think maybe a lot of you are quite curious about how these photos are actually taken. So both of these photos are not one-shot photos. They are, I would say they are composite photos. For this one, they didn't mention about it. But for this one, the author did mention this image is made out of 35 exposures. So this is just one image. So what is meant by 35 exposures? So what I can understand is that the method I know is that basically they will took a lot of photos. So maybe in one exposure or one photos, it will only contain maybe like one or two meteor. So, but with the same background. So in the post-processing, they will kind of like overlap all the photos and kind of like remove the other part, but only combine the individual part which contains the meteor. Okay, so after combining all the image into one, this is the result. So it's a kind of tedious processing work to produce this kind of image. So I think like in artistic way, I think this is a very good photo, which I think the photographer may use some kind of like soft filters or something like that. But I mean, the photos looks very pleasing to me. But for this, there are something impressive, which you can see. There's a bright lines over here. So this is for sure a fireball. I think a fireball is the tail, or is the tail is a meteor produced by the relatively bigger meteoroid. Yeah. So from both of this image, also from the directions of all the meteors, you will know where is the Gemini. So as you can see, this is Castor and Pollux. So this is Gemini. Okay. So the direction of each meteor is actually pointing to the radiant point of the meteor shower. Okay, so we have something more. Let's talk about this. So this is another astrophoto, which personally I would just call it the spaghetti nebula. But yeah, this is a technical name. It's under the catalog S147, which the title also mentioned is a Supernova Remnants. Basically, this is a remnant, which is the remains, or you can think of something like it's the dead body of a dead star. So when the star life ended, it exploded, and this is what's left behind. So what's left behind are gases, dust, which you can clearly see there are two colors. So this is actually not a true color image, which means let's say like in a general term, this is actually taken using two different filters. So if you try to read the description, you will see something like this, like taken through narrow band filters. So what is actually narrow band filters? Narrow band filters are filters that only allow a small range of wavelengths of light to pass through. So you only get a specific range of wavelengths of information. So in this image, they use two different narrowband filters, which the author also mentioned that the reddish emission is the emissions from the ionized hydrogen atoms, and another color, which is doubly ionized oxygen atom, which is represented by faint blue-green hues. So this is the blue color thing. So this color is actually designated by the processor. So basically, the author will alternate the colors to sometimes signify the difference, to visualize what is over there. So yeah, this is about the Spaghetti Nebula. And then there are two important events happen in this month, which is very exciting. So since both of these are video, so I will try to play it one by one, since it is not too long. So what you can see a kind of like a meteor. Yeah, it's a kind of artificial meteor over here. So what is this? This is actually the return capsules uh, of the Hayabusa 2 mission, which I think last year, last year, or I think more than 1 years ago, Dr. Chung they had a talk about the Hayabusa 2 mission, which is a sample return mission from an asteroid called Ryugu, which is a very challenging mission. And what is cool about that is that in this mission, they successfully bring back, I think, 5.4 grams of the sample. So what is important about this mission? The aim of the mission is actually to study how the waters and organic materials comes to be on Earth, which both of them are believed to be the fundamental materials or molecules. Two of the main things contribute to the existence of life. So that's why scientists wanted to study more and understand more about this. And these trials is not happen in Japan. Oh, by the way, if you are not familiar, this is a mission under JAXA, which JAXA stands for Japanese. Basically, JAXA is a Japanese space agency, I would say. But this trial or this artificial meteor or this return capsule is not landed in Japan. It's actually landed in Australia, which I will show you some images. Okay, what you can see over here is the return capsule with the parachute landed in Australia. Yeah, you can see the crews, the members is holding the return capsule, which the samples, 5.4 gram samples is hiding inside. And they try to pack it up and take it back to the base in Australia, and then sent back to Japan. Yeah, so this is the mission control of the mission, and this is actually the trail when the Hayabusa 2 is still orbiting around the Earth before the attempted entering into the Earth atmosphere. Okay, so these are the images, and this sample, because of this mission, I try to find out more about the mission. So I think I kind of found their mission control. So this is Japan, this is Tokyo. So I think their mission control is over here. It's over here. So this is actually a complex, and which I found out is open for public but just a small section over here. I think the mission control is just over here, and I think it is logical to say that the Ryugu asteroid sample is right over here, which is very close to the place I stay. It's very close. So I think it is back in Japan, but I'm not sure when they will put the samples up on exhibition, which I'm quite excited to have a look at the sample. And then, we have another big event. Yeah, this is a very disastrous event happened this month. So you can have a look at the motion picture, which is the video first. So what you can see is that, so maybe I'll have a little bit of introduction first. So as you can see over here, this is Arecibo telescope collapse. So previously, Arecibo telescope is the largest one dish or single dish radio telescope in the world, which the record stands for I think around 50 years. It's roughly 300-meter radio telescope. What happened is that actually before the collapse of the telescope, I think a few weeks before the final collapse, I think one of the cables snapped and part of the telescope collapsed. But I think just 2 or 3 weeks after the news, another sad news come out, which you can see the whole things. This part actually snapped and the whole platform collapsed, and consequently the whole dish actually collapsed. Yeah, which is a sad news. And as you know, this is located in Puerto Rico. So I think after the collapse, I kind of try to understand the situations, and from the news, I understand that it's actually a very sad moment for Puerto Rican, because of these projects. I think throughout the 50 years, there are a lot of radio astronomers born from Puerto Rico, and radio astronomy is kind of like a dream of kids in the country. I understand that they promoted a lot on the radio astronomy educations among children. So it is, I can kind of feel it. I can kind of understand that is how sad it is for the people to lose such a opportunity and such an iconic symbol of the country. But although we lost one of the big eye to observe the radio universe, we still have another alternative, a slightly different alternative, which you may already know, which is known as FAST, in short, which is currently the largest single-dish radio telescope in the world, located in China. So what I understand that is that after the collapse of the Arecibo telescope, the committee of managing the telescope, I think the academicians over there, they say that now they are planning to open up the application to use the telescope for international scientists, international astronomers by next month, which I think is a very good thing to encourage. I mean, it's a very good step to keep the radio astronomy developed in the world. Although this is, by the way, this is the diameter is around 500 meters, which is 200 meters longer. The diameter is 200 meters longer than the Arecibo telescope, but they are, if you compare both of them, this is just a single dish, and this is, you can see there's no another platform like the Arecibo telescope, as you have seen just now. So for these things, what I understand is that the scope has only kind of like a single focus point. So like if they observe over here, so kind of like the scope cannot be steered, because like for the Arecibo telescope, the platform is actually can be moved around. So the telescope can see, the Arecibo telescope can see a wider I would say, a wider area of the sky and can be focused on different areas. So I would say it's two kind of different ways of the two kind of slightly different radio telescope dish. But sadly, that was destroyed. So I'm not sure whether American will be spending on another big radio dish, but let's see what will be happen later on. Yeah. Oh, yeah. By the way, I have one more image to show. So for the about the Ryugu, the Hayabusa 2 mission just now, this is the latest image from the Hayabusa team, which you can see the sample from two of the chamber A and C. I still don't. There are actually three chambers in the return capsules, and they actually try to collect the samples for twice, like the first landing and the second landing. As you can see, as from the reports, they say that the particles or the samples actually looks and feel like kind of like a charcoal. As you can see, it's dark black, but they haven't published any scientific report yet. Just some basic information only. But you can see the labels over here is kind of like a metallic piece, but they didn't mention much. Which the labels over here is kind of like means it means that it looks like a man-made object, but they didn't clarify much about what this is. But maybe in 1 or 2 weeks we'll know more about the sample. So that's all from me. Maybe Dr. Chung can continue with the rest of today's session. Dr. Chung.
Thank you, Hong Juan from Tokyo, and thank you, Lai from Penang.
Yes.
So we continue with me now. All right. So I will present. So Hong Juan, still a lot of food left. If only we can teleport the chicken wing to you. Yeah.
Yeah, my stomach still have some space.
Yeah. If you and Dan are here, wow. Okay. Can you see my picture, Hong Juan?
Yes.
Yeah, no? All right. So, okay, we will continue on take away from Hong Juan just now. So, December the 9th, Mammatus clouds over Mount Rushmore. Right? Look at this. So, this is where? In the United States. This is a big picture. Let me reduce. So, it's taken by Lorraine Matusi. It's an ordinary woman tourist from France visiting America, the state of South Dakota in USA. Right? So basically, you see, he was there. She saw this scene, and this is a special type of cloud called Mammatus cloud. So basically, you see in Malaysia, you find that you have the so-called cumulonimbus cloud, the thick kind of cloud in the sky. But in certain countries, below the thick cumulonimbus cloud, this type of Mammatus cloud can form. It's quite big, The diameter of one of the round object here can be 1 kilometer in diameter. So what happened is, they saw the Mammatus cloud, just above Mount Rushmore. So basically, there's not much to do with astronomy, but weather phenomena. Now Mount Rushmore is in the northern state of South Dakota. And of course, here you can see the picture of the 4 American presidents. Don't say they're small, So this is carved into the mountainside, very big. So if you see carefully, on the left is what? If you're American, you should recognize. So I'll make it bigger. All right. Okay. On the left is George Washington, the first American president. They got independence from where? From the Red Corsair, from the English army. All right. George Washington, first American president. The second one on the right is Thomas Jefferson. The third one is, of course, Theodore Roosevelt. And the furthermost right is very famous, what they call Abraham Lincoln. So you see all these interesting cloud about Mount Rushmore. They carved it in this place more than 100 years ago in South Dakota by an Italian woman who was very surprised to see there, and she just snapped the picture there. All right, Lorraine Matuzzi from France. All right, we continue for the 5th of December. Big all the I enlarge it now. 5th December. Okay, Mons Rumker in the ocean of storms. Some of you should know lah. All right, Chang'e 5. All right. Okay, so basically, it's taken by Jean-Yves Letellier, a French astrophotographer. He took it from France. So basically, you will have in the northern part of the moon, there's a place called Sea of Storms in English. In Latin is Oceanus Poscillarium. And there's a 70-kilometer, what they call, kind of protruding dome, Mons Rumker. But Chang'e 5 didn't land here, but somewhere to the northeast of here. Remember, it recently brought back from this part of the moon 1.7 kilogram of moon soil and moon rock. All right. So how much is 1.7 kilogram? I look at this. I like to eat McD filet of fish. This is about 140 grams, you know. So basically, the moon rock and moon soil they brought back from the moon is about 12 filet of fish. So with that amount of moon rocks, 1.7 kilogram of moon rocks and moon soil, a lot of research will be done. So now I'm very sure the Chinese scientists have opened it in the laboratory in Beijing. I'm sure they will study it. And why is it interesting is the area of the moon where they landed is relatively young. How young is young? Very young. About 1 billion years old. 1,000 million years old in astronomy is very young. The other parts of the rock taken from the other parts of the moon by the American and Russian mission were 3 billion years old, 4 billion years old lunar surface. But this is 1 billion years old. So hopefully the information they will get here, new information. So now I'm very sure now the Chinese scientists will be doing this, scratching their head. Why scratching their head? They will have to send some of the sample of the moon rock, moon soil to various scientists around the world. To which scientists? America, Russia, England, Japan. I hope they can send at least 1 gram to Malaysia. We can study. All right. So the moon rocks from the Chang'e was taken from here. And this picture of the place they landed to the northeast of Mons Rumker by a French astrophotographer, Monsieur Jean-Yves Letellier. Right. So here we continue. December the 3rd. There you are. Antenna Galaxy. Okay. So whenever I look at the antenna, this is not your astro dish. This is whenever I look at antenna, I always tell myself, wow, wow, wow. Why? Ladies and gentlemen, this is a colossal catastrophe. What is this? This is one spiral galaxy, and this is another spiral galaxy long after colliding with each other. So previously, this galaxy on top and below are separated. They are like spiral galaxy, but they actually will move slowly and collide. All right. So this one is taken by ESA, European Space Agency, Hubble, and NASA. Whenever you see Hubble, Space Telescope, you usually mean you know NASA and ESA. Because NASA and ESA are combined together, their data. So basically, this big spiral galaxy is colliding. And you see, this called tidal interaction. Now, you may say tidal interaction means the water in the sea will splash onto the seashore and splash out the tides. No. This tidal interaction is caused by the gravity force of the billions of stars in this galaxy on top and the billions of stars in the galaxy below. The gravity of these billions of stars are affecting each other. And this, remember, our Milky Way is 100,000 light years in diameter, no? So this could be 100,000 light years in diameter, and here also 100,000 light years in diameter. So when you have two galaxies colliding, so this is called a galactic collision. It's not, for example, on the Earth, you see two balls hitting each other in the surface of Earth, they collide each other, they fall down. So basically, the gravity travels what? With speed of gravity, no? But on the Earth, because the Earth is very small, so when two objects collide on the Earth's surface, we know that whenever they hit each other, and you look at the collision, it's instantly it occurs, and you see instantly because you are very near to the object. Because speed of light is very fast. But no, light takes 100,000 light years to travel from here to here, and light takes 100,000 years to travel from here to here. Gravity travels at the speed of light. So gravity travels from here to here, 100,000 years. Gravity travels from here to here, 100,000 years. So basically, this is called what? It's called a retarded potential. That means the gravity, imagine that some of the stars here have a collision. The effect of the gravity here will only be sensed here 100,000 years later. Cannot be seen instantly, right? Because the faster that the gravity can travel is the speed of light. So the gravity travel across here very slow. It takes the gravity effect to travel from here to here 100,000 years. Similarly, from here to here 100,000 years. So you have to take the delay because this is a very big part in the space. So it's called the retarded potential. So it's a kind of a very distorted kind of collision. It takes years and years. So basically what? Here are billions of stars were affected by another billions of stars here. All right. And so basically the two galaxies shape what? Habis lah. One habis. Distorted. Gravity of the galaxy on top and below distort the shape of each other. Some of you may say, but I thought that you have imagine my right hand is a galaxy, left galaxy. I thought, wow, if the two galaxies collide, that means all the stars in galaxy A and the stars in galaxy B, they'll hit each other, toing, and they hit, and the stars will fall down. Cannot be, because in space, up and down, left and right is not defined. No weight in space. Because actually the space in between the stars in the galaxy is vast. Very unlikely to have the stars in galaxy A and the stars in galaxy B actually hit each other. Very unlikely. Maybe out of the billions of stars in galaxy B, A, and billions of stars in galaxy B, maybe one of the star A and B can collide, but the rest of the stars don't collide. What happened? The rest of the stars in galaxy A and B, they interpenetrate between the stars. So actually what is affected is the dust and the gas in between the stars, they are heated up. So what happens is when you have the two galaxies collide, the space between the stars, the interstellar space, so gas and dust will interact and they heat up. They heat up to form what? To form radio wave. And if the heating is more, will form infrared. It will not form X-ray and so on, but maybe strong radio wave. So basically, the gas and dust in between start to interpenetrate. So this is a strong source of radio wave. If there are any alien there, they use handphone, useless handphone. But the background radio wave, it will drown out all the radio wave from the alien civilization. So don't go inside there, very dangerous, a lot of radiation. So this is the antenna. So you may say, has the galactic collision been played out? Not yet. I would say, maybe after 2 million years of collision. You have to wait for a few million years in future to see the galactic collision played out. So what is going to happen? It's like this. Two galaxies collide, they penetrate. There are few scenarios. One is that if the galaxy A and B have fast speed, they can penetrate each other and fly away from each other, and the shape of the two galaxies becomes distorted. And then the two galaxies fly away from each other, never come back. But another possibility is, if the two galaxies collide, the speed are slow enough, then interpenetrate, but it cannot fly away. It will go further away, and then the mass of the two galaxies will pull them back, and they will chop over billions years, form and merge into one galaxy. Ladies and gentlemen, do you know that our neighbor in space, the Andromeda Galaxy, is the result of a merger of two galaxies? Previously, the two spiral galaxies collide and now form to one big spiral galaxy called Andromeda Galaxy. But in the center of Andromeda Galaxy, they found that there are two sources of light orbiting each other. So that means previously, Andromeda was two galaxies like this, collide. So many years later, you collide, and if they merge with each other, they will form a new spiral galaxy. But actually, it's a collision of two earlier galaxies, right? We continue to the last one, 2nd of December. I really like this. Wow. All right. I make it bigger. So Michael, this is the last picture. 2nd of December, I tell you, this guy, look at it. Oh, I make it smaller. Wow. Smaller. Wow, pingsan. You see what happened? The photographer, Zachary Cooley, he's not a astronomical photographer, not astronomical, he's a landscape photographer. What do you mean by landscape? The guy bring along his camera and travel anywhere in America. Suddenly interesting landscape, he take. But at that time, the landscape was the moon. So basically, it's what? The Arches National Park in Utah, USA. Utah is a state in the central part of America, not of Colorado, south of Canada. So basically, this guy, the camera, and he was lucky. There's a gap in between the arch there, and he went and saw the moon, not too close to the moon. He got too close to the moon is so big, the moon will cover the whole here. Cannot, not nice. You go too far also cannot. Too far, no. Too near cannot, because too near, the hole is too big, the moon is too small. No, not nice. You go very far away from this hole, that means the moon is too small. The hole is small, the moon is too big. Not nice. It must be ngam lah. That means here, the moon just fit into the hole. This hole is called Eye of the Moon, and then there are some of the tourists there, but he made a mistake. If I am there, I say, hey guys, all put up your hand and say, wow, wave your hand at me and then behind is the moon. I really like this. So this is taken one in daytime. Are you sure you can see the moon in daytime? Of course. He's a nice guy. So basically, this guy, Zachary Cooley from America, must be traveling with his camera, and he saw it. I'm very sure when he saw the moon was not at the hole here. He might kept traveling for some time, and then found this is the correct position, and maybe the sun is setting. Better to take a picture fast. If not, the sky becomes nice. Snap a picture. Very nice. So it took a lot of planning, So I explained here, a lot of planning to get this, So basically, when you take a picture like that, first of all, what? Luck. You're lucky that the moon is there, and you're the area got this hole here, and then you do some planning, you find there, and then you took a picture. It's worth it. All right. So this is by our Mr. Zachary Cooley from USA, Arches National Park, Utah, USA. All right, that's it. So I think that's about all. Maybe I just want to wrap up. So to our listeners and observers on the internet, is that when you look at this astronomical picture of the day by NASA, it's not just astronomy. No, you learn a lot about culture. You learn about culture, different country, different culture, and also about equipment. What telescope? And sometimes you learn about how did the nebula form, how did the Saturn, Jupiter form. So basically you learn all kinds of information. You never know it comes from what direction. All right. The important thing is, at the end of the session, if you look at December, you'll tell yourself, oh my, sorry, I said, I learned so much to all kinds of information. So before you sleep, after looking at December picture, you see, I have become a better person. I appreciate the astronomy, I know about telescope, I know about image processing, all right? And I know about what is taken by people around the world. So that's why it's very nice, all right? So this is, I feel that this is the best picture archive I know on the internet. Of course, specialized one called Hubble Pictures, only on Hubble Pictures, and like very large telescope in Chile also can. But this is what I call what? The Roja website. Roja means from any site, from any person, everywhere in the world. All right, very nice. This is the best astronomy picture website in the world. All right, and it doesn't mean that you must be an astronomer to do it. Like for example, I told you this one, just one more, and then we stop. Remember, I show you that this French woman tourist from France passing by the Mount Rushmore monument and took the what? The magma cloud above Mount Rushmore. So anything can happen, right? So I think that's about all, Michael. Thank you, Michael, and Lai and this Hong Xuan in Tokyo. Yes. Any question for us?
I looked at the comment session so far. It seems like no question for us today.
Yeah.
Yeah, but this month the airport is very interesting and it's quite difficult to choose. I was expecting I chose only 15, but end up I chose more because all are good pictures this month.
Yeah.
Very good picture this one.
Yeah. I really enjoy it.
Yeah, I think this month has a lot of interesting events.
Yes.
Yeah, so I think that's all for us today. I think we can stop the live session first before we
Thank you very much.
Once again, thank you everyone for joining us through this Facebook Live of this APOD session. We see you all end of next month.
Yeah.
Bye.